Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at the homework for lesson 3.1.7. We're doing problems 65 through 69, so let's get started on 65. So here it says, one of these points is not like the others. Plot and connect the points listed on this table below. All right, so plotting those points, you would have gotten this as your graph. So point A is at -2, 0. Point B is at 4, is that even on here? 412, yeah, there it is up there. Point C is at 1, -3. Point 4 is at -4, +12. So you see this a parabola and you get your mirror image, right? Your symmetry, these guys are symmetrical to each other. They're both the same distance away from the y-axis. Point F is symmetrical, should be symmetrical to a point out here, which would be -3,5, because this is +3,5. And then you've got this point here, which is point H, which is 2, 0, which matches up with point A, which is -2, 0. And then C, and an imaginary point there. And as it turns out, one point that doesn't seem to fit is -3, -2. So that's not, this point should not be on the parabola. There's no matching point on the other side. So I'm not quite sure why that is there. Now they are kind of, what are they asking? What shape is it? It's a parabola, and then correct the point. I wasn't honestly sure how to correct the point. Because it's like, all right, did they make a mistake? Is it supposed to be -3 for the x, so that should be +5? That would work if this was -3,5 to go along with this one as 3,5. Or maybe it was supposed to be -1, I don't even know what that would be. Oh, I guess 1, -3, and -1, -3. Why did I put this point right there? I don't know why that's there. Get out of there. You do not belong. Okay. So I guess it could have been either this one or that one. Maybe they had the, now even so, I'm confused. It probably was supposed to be this one right there, not that one, even though that would be another one that would match up with C. So there we go. For each rule below, make an XY table and then graph the rule. So y equals x squared. That's pretty much the basic graph where, you square the value for x. So 1 squared would be 1, -1 squared would be 1. 2 squared would be 4, -2 squared would be 4. 3 squared would be 9, -3 squared would be 9. So you plot those points, and that is that generic parabola for y equals x squared. Now notice what happens when it changes to y equals the opposite of x squared. You end up getting the same exact parabola, but it is now tipped upside down. So the vertex is the same for both of them. They both have a vertex of 0, 0. But in this case, when it was -x squared, it ended up going down, which now becomes a basic rule for you to follow. If you're dealing with a parabola where the number in front of the x squared is a positive number, it will always form a U shape with the arrows pointing up. If you have an x squared with a negative number in front of it, in this case -1, then you are going to get a U shape that is going down. The arrows are pointed down. So something for you to think about in the future. In fact, if I were to right now just say, all right, let's say y equals -3x squared, I can tell you that this is going to be a parabola where the vertex is going to be its highest point and it's going to be pointed down because of that negative in front of the 3 for the -3x squared. So now for the other parts, it says for the graph for y equals x squared, estimate the value when y is equal to 5. So when y is equal to 5, that's this point right here, right? We're counting by 2, 4, 6, so 5 would be there. So our estimated values for x's there would be somewhere a little bit beyond +2 and a little bit less than -2. So I estimated it to be somewhere around 2.2. And then for the other one, when y was equal to -10, then here's -2, -4, -6, -8, -10, then it looks like this is going to be somewhere around 3.5 maybe, right? 2, 4, so about 3.5 for each one of them. Where I said 3.2, it's kind of hard to tell from a graph. Once again, if you don't draw the parabola perfectly, it's hard to get an estimate, but you got a ballpark figure somewhere between 3 and 4. All right, the amount of money Teresa earns at her job varies directly with the number of hours she works. This is a way of saying that it's a proportional relationship. Okay, so varying directly. Oh no, what did I do? Varying directly tells you it's proportional. So she knows that when she works 2 hours, she earns $12. So you can figure out the unit rate and say, okay, well, that means she's earning $6 per hour. Same thing here. When she earns 3 hours, or when she works 3 hours, she earns 18. So does that fit in? Is 3 times 6 equal to 18? Yes, it does. So how much would she make in 5 hours? Well, 6 times 5 is 30. And use the unit rate to explain how you can find Teresa's earnings if she works X number of hours. So this rule here pretty much takes care of that. So you multiply the unit rate times the number of hours worked, and that will always give you the amount of money that she makes. And when you plot these points here, she doesn't work any hours, she doesn't make any money. 1 hour is $6, 2 is 12, 3 is 18, 4 is 24, and 5 hours would be 30. So that forms a straight line because it's a constant growth rate. She's making $6 per hour, and it goes through 0, 0, because if she doesn't spend any time working, she will not make any money. All right, last 2 problems. I'm not a huge fan of these types of problems, trying to identify properties or steps, but it's good to think about. So left expression, 3x squared minus the quantity 2x minus 4, you'll want to use distributive property here and change that to -2x plus 4. And then you can begin the process of removing balanced sets. And then you get -2x plus 4 equals, you combine like terms there. They didn't really tell us to do that, but that's what I did. And now subtract 4 from each side, and you end up with -2x equals 0. So if that's the case, then what do you multiply times -2 to give you 0 for an answer? It must be 0, so x must be equal to 0. And now for the diamond problems. Remember, these are the 2 magic numbers. When you multiply them together, you get the answer on the top. And when you add them together, you get the answer on the bottom. So multiply 3 1/2 times 1/2 to get you 1 3/4, and add them together to give you 4. Go ahead and take a look at the answers. If you have any questions, let me know. I will work this out for you. Otherwise, we've done diamond problems so many times. I'm hoping you're an expert at it by now. Okay, I might go over this one quickly. You just ask the question, what 2 numbers have a total product of 10 that when added together give you 7 for an answer? So 1 times 10 is going to give you an 11, and 2 times 5 will give you the 7, so it must be the 2 and the 5. All right, less than 9 minutes. That was fast. All right, take care. Let's move on to the lesson. Bye.
Hey, feeling good, like I should. When in dark,